Good day, students. I thank you once again for, visiting my channel once again to learn what we call probability distribution. I give special thanks to God for blessing us with this day to start our studies on probability distributions. I give a thanks to my friend Ajimai, who is in Department of Physics at Kwame Nkrumah University of Science and Technology. Was the sole motivator for me starting my YouTube channel. So, Mr. Ajimai, God richly bless you. And then today's class, we are beginning a full course on probability distribution. As I said, probability distribution is very, very essential for, in fact, every student to know, right? Especially the statistics student, because many decisions in businesses, insurance, and other real life situations are made by assigning probabilities to all possible outcomes pertaining to the situation and then evaluating the results. So, for example, a saleswoman can compute probability that she will make 0, 1, 2, or 3 or more sales within a day. So, in this concept, we are going to explain the concepts and then application of what is called probability distributions, and then discuss some special probability distributions under both discrete and continuous cases, right? But before we go on to explain probability distributions, I would like us to remind ourselves on variables and what we call random variables, right? So in statistics and probability class 1, we learned something about variables, and we said variables is defined as characters or attributes. So, for example, alphabets such as X, Y, and Z are used to represent variables. And then for random variables, we said that they are variables whose values are determined by chance, right? So, for example, if we really want to toss a fair coin twice, right? This will be our sample space. That's head, tail, head, and head. Right, this our M is our sample space, right? So at the end of the day, we will get a random variable under this. So let X represent the random variable for the number of hairs. So here our character of interest is the number of hairs. So when we come to the sample space, we will either have 2 hairs, 1 head, or no head, right? So here our X will be 0 for where you don't have no hair, where you don't have any hair, and then 1 where we have 1 hair, and then 2 for where we have 2 hairs. So here our X is equal to 0, 1, 2, right? And most of these random variables are associated with probabilities. So here our X, as you can see here, is the random variable. The P of X here, you can see there are the probabilities, individual probabilities assigned to the random variables, as you can see there. And the random variables are grouped into 2. We have what we call discrete random variable and then continuous random variable. So let's tackle the discrete random variable. After that, we go to the continuous random variable. So the discrete random variable are variables that have finite number of possible values or infinite number of values that can be counted, right? So basically, all that we are saying about discrete random variables are they are variables that can be counted. So, for example, let X represent tossing of a coin once. So, if you toss a coin once, we know the number of possibilities that will come out. That is the head and the tail, right? So, the number of this outcome can be counted, right? We have 1 and the 2, right? 2 outcomes. So, our n of X, right? Our n of X will be equal to 2 because we can count them, right? And then we have another one. It said let X represent tossing of a die twice. Once you toss a die twice, we are going to have this table to get our individual observations. So 1 and 1 will give us 1 and 1 here, 1 and the 2 will give us 1 and 2 here. So once you finish filling up this table and then count them, we are going to get our NT to 36. Of it, this will be this is of the observation 1, 2, 1, 3, 1, 4 up to 6, 6. Once we count it, we are having 36 observation. So these are countable. So basically, discrete random variables, they are variables that can be counted, right? So under discrete random variables, we have what we call probability mass functions. right? So all the probabilities and our discrete random variables are represented by probability mass function. So for example, assuming probability of xi is one individual probabilities, then the function p of x, where a p of xi, where the I is 1, 2, 3, 4, right? Satisfying the condition is called what? Probability mass function, right? So if we are having a discrete cases and that discrete cases certified what this condition, probability that our xi is greater than, right, or equal to 0, probability that our xi is what greater than or equal to 0 for all i's, and then the summation of our probability of our xi's is equal to 1. Then once this condition is met, it is called a probability mass function for what? Discrete random variable. So let's walk through some example for us to really appreciate the probability mass function. So for example, if x is a discrete random variable having probability distributions, then we could say that so this is what the table giving, right? So we are here we are supposed to just check if if it satisfy what the condition for probability mass functions, right? So the first condition is that the probability of what xi's must be what strictly must be greater than or what equal to what must be greater than or equal to what 0, right? So at the end of the day, we are having this one. So once we come here, we are having probability of x0 is equal to 1.5, probability of x1 is equal to 2/4, probability of what x here is x1, here is x2 is equal to 1/4. So at the end of the day, you see the first condition is met, right? The second condition is saying that summation of what p of xi is equal to what 1, right? Summation of p of xi is equal to 1. So at the end of the day, we are just going to add the individual probabilities that was associated with what the random variable, the x, right? So once you add 1/4 plus what 2/4 plus 3/4. Once we add this, we are getting 4/4, which is equal to 1. Hence, it is what the probability. It satisfies the condition for probability mass function. So this is considered as what probability mass function, right? So that is in that case. And then let's come to what continuous random variable. So for continuous random variable, we learned that once all variables in the interval between any two points are given, it is obtained from what data that can be measured rather than what counted, right? So for continuous random variable, they are always in what an interval forms, right? They are always what measured. You cannot count continuous random variable. So for example, let x be what the temperature within what 24 hours, and then let x be what the height of our student in a class, right? So you see that for temperature we cannot measure and we cannot count temperature at 1, 2, 3. So when you go to the hospital specifically, they usually calculate your temperature and the height, right? So at the end of the day, you see that when they measure the temperature, they measure it in a certain grade for you to know that, oh, this person is having a normal temperature, right? So that they will give the right treatment and medication to you, right? So here we don't count temperature, but rather we measure them. For the height too, we measure them, right? So these two are specifically an example for what continuous random variable, right? Continuous random variable. So for continuous random variable too, they have what you call probability density function, right? And then before continuous random variable will be considered as probability density function, then it must first certify a certain condition, right? So assuming p of x is an individual probability certifying the condition below, that f of x must be greater than or equal to 0 for all xi, and then some integral of what f of x dx must be equal to 1. So once you integrate this probability function f of x with respect to x and is equal to 1, then once these two conditions are achieved, then this is what probability density function, right? So these are basically what we did under variables and random variable under probability and statistics 1 class. And then I really wanted us to go through so that before we start our probability distribution class, right? So kindly go through this one more. In our next video, we are going to discuss something on probability distributions, so that at the end of the day you really appreciate. Thank you for joining my channel. This is Statistics and Mathematics Twitter channel. Please kindly like, subscribe, and then share so that others will benefit it. Thank you. Bye.